So I did this. I'm like trying to figure out if I want to try and raise money to do a second batch. I have some interest from people who want to buy it, but I was like,
I feel like I might have seen this.
yeah, maybe I presented at like the hardware startup stuff.
Okay.
But so it's like, yeah, I'm like, well, this is a project which I like, but it's like, that's like a high good amount of money to do a second run.
Yeah.
I'm using USTX on Dripping Springs. I don't know if you're familiar with them.
Yeah.
It's pretty good. They're really flexible, which is what most of them I need.
Are they doing everything?
I have another guy in town's doing the case, the wood case.
Okay.
Packaging is somebody else, but they're putting it all together and doing the PCBs.
Cool.
So yeah, it worked out. It was like, I got them out. Like I didn't lose money. I was like, okay, that was a success.
Yeah. Yeah. Were you able to make any margin, or was it all just like covering the cost?
For this one, it's like pretty much breaking even. I think the next batch I actually could. Like I know what I'm doing more now and have a lot less waste. So
That's cool. Yeah, I like it. Graphics.
yeah.
How big was your run?
We did 500.
It's not nothing.
No. It's like, especially when I'm the one that actually just got an email. It's like, mine's cracked. I'm like, okay. Like, you know, and 500 individuals is a lot.
Yeah, I would feel bad taking your precious inventory.
Oh, no. I intentionally.
Okay. Alright.
This is part of my marketing strategy too. It's like meet cool people who are doing things I like and like. Yeah. So. But,
What's up, man?
How are you?
Good.
Saw your name popped up. I was already down here for a meeting. Good. Been my food trip.
Yeah.
Coming up. A couple weeks.
We're over there.
All in South John.
Yeah.
I think so. I tried to call the organizer. There's a guy from New York that kind of started that journey there.
Feel free to shout out if you have ideas to add.
All right, no problem. No problem.
All right, I think we'll go ahead and jump in here. I have my exciting podium here. No mic, so I'll try to project as per usual, you know, about 100 RSVPs. About this is a pretty good turnout actually for a startup week thing. Thank you guys. And as always, everyone's like clustered in the back. So anyway, today we're talking a little bit about prototyping, specifically sort of lightweight, iterative, low cost, high value prototyping. Over the years of working in product design, digital and physical, I've seen a sort of trend towards prototypes becoming sort of more and more sophisticated, more and more high fidelity, ultimately more expensive, ultimately slower to create. And it's sort of, I feel like we're starting to lose a little bit of the spirit of innovation, the spirit of sort of rapidly making things to answer questions. So if anyone in the room has been involved with building a product before of any kind, you've most definitely made prototypes. So we're not just talking about prototypes, we're talking about sort of quick, rapid prototypes. A little bit on my background. I'm a co-founder of a creative design consultancy here in Austin. We work on physical and digital products. We have a mixed team of both, interaction designers, strategists, hardware designers, and so we make a lot of different things. The area that we're most passionate about and we focus most in is sort of the connected device space, so things that have one foot in the digital, one foot in the physical. And so that's where a lot of my examples will come from today, and a lot of things that I'll touch on are a little bit more in that connected device IoT space. But honestly, the philosophies of rapid prototyping apply across the board. So even if you're working on a manufactured good that has no PCB inside it, or you're working on a piece of software that's never going to have a manufactured good or a consumer electronic that works with it, don't worry about it. But what I will do is I will frame it in terms of sort of what's happening in our market a little bit, what we see sort of in the Western markets, especially in the consumer space. I make the argument, I think a lot of people are making the argument, that really we're in sort of the experience economy now. So where we had a lot of sort of classic ways to have clear differentiators, like being first to market, or being the price leader, the feature leader, being the fast follower, these sort of classic sort of MBA style ways to give your company an edge. Those aren't irrelevant by any means. I think a lot of that still applies, but what I think we're seeing more now is that consumers are really drifting towards and choosing to spend their dollars against experience that they like. So you'll see this play out pretty frequently where, 3 startups will come to market at the same time. One of them's just got like the huge feature list. One of them's like really cheap. And then there's this guy in the middle who, he's not the cheapest, he doesn't have the richest feature set, but he has just really designed that experience to be really seamless, really rewarding to use, and that's the one that wins. We see it time and time again. The brands that people are passionate about and they're giving their money to right now are the brands that are generating great cohesive experiences. And so I'll use brand and experience pretty interchangeably because I think that's sort of how we all need to be thinking about it, right? Your company's brand is merely just a set of interactions that people had with it, from the first piece of marketing collateral they saw, to their in-store experience, to their at-home, out-of-box experience, how hard was the thing to set up. All of that is really what people perceive as your brand, and rightly so. So when we're trying to generate experiences that make sense for people, we're trying to think very clearly about all the places in which they're going to touch them. And in a world of connectivity, that is just a proliferating set of checkboxes we have to now tick, right? Whether you're making an IoT product or you're making, just a nice standalone good, it will still have a digital life, right? Everything's going to have that digital footprint now. And so figuring out, how we connect all these things together is a real challenge. I also think what we're seeing a lot now is as we push into the connected device realm, we're starting to see very new ways of interfacing with things. We had a very consistent way in which people interface with things for a long time. Whether it evolved from a mouse and keyboard to a touchscreen, it was still a very direct interaction modality. So you see an interface, you do something, you get this immediate feedback. You have this very nice closed loop. And now, you might be controlling your thermostat that's at your house, across the world from you. And so you just introduce these distance gaps, these time gaps. You're starting to add in more rule-based UI where I might set some rules like, oh, if this happens, then I want this to happen. If you see my kid come home from school, then turn the temperature down, right? So you're getting into a lot of different, really drastically different styles of interfacing with devices and software, and that creates a lot of room for people to have, unfortunately, bad experiences. I was speaking on a very similar topic up at an IoT conference in Boston a few weeks ago, and my Nest Cam went offline and my Nest went offline, and it was giving me no indication as to what was happening, why it was happening. My dog was there, it was hot, I was worried, the house sitter, very confusing. And so that's an expectation that was set for me of how that interaction is supposed to be, and then it was broken, right? So very hard when you're in the lab, when you're developing a product, to think through all these possible implications, but increasingly important. So what I'd like to argue is that we're really more systems designers now, right? We don't get the luxury of getting to be hyper specialists anymore, even if our trade is one thing specific, even if we are developers by nature, designers by nature, web designers, hardware designers, electrical engineers. We have to care enough about all the disciplines that surround us, all the other people on our team, because ultimately, how a user experiences our product is not, oh, a piece of software that this guy built, I'll judge that by itself, and then I'll come over to this piece of hardware and judge that by itself, right? They're judging the sum of all the parts they touch. And to add a little more complexity to it, there's just these real world challenges of hardware. As we move in IoT, I used to bitch and moan. I come from an interaction design background. I spent a lot of time in web. I used to bitch and moan about like having to optimize across a bunch of browsers and a bunch of OSs. And then when we got mobile, I started bitching about that too. And forget it. You get into hardware, it's 10 times more complicated. I've had a crash course building this company. My partner, my founder, he comes from this world, the hardware world. I come from the software world. They got it so much harder than we do, right? And so there are just these physical things that you can't overcome unless you're going to invent a new piece of technology to do so, right? I mean, most of these devices are connected through some sort of wireless communication. Wireless communication is a pain in the butt. It requires crazy antenna design. You have to be, thoughtful about what the housing is and what the material properties are. It gets bounced off things, like, forget about it, right? And the feedback cycle to a user is so confusing. Then you got battery life. Oh my God, right? So finally you've got the radio working well, and then you turn around and it's just chewing up your battery life because it's pinging, your hub station. So real world hardware is something that we have to take into consideration. We can't just wish it away, and we can't design for the ideal use scenario in which the person's really good about turning it off when they're done. No, we have to design for the worst possible scenario and make it still make sense to the user. It's not saying we throw up our hands and say, screw it, that's as good as it gets. It's about saying, how do you proactively get in front of what might be confusing? How do you solve the problem once it starts? And the last thing, I don't know how many folks here run teams or leading organizations, building new organizations. It is Startup Week, right? But there is a very significant organizational challenge with bringing these connected products and devices to market in a way that makes sense. So as this great new smart home device you're building, ping-pongs its way through your team, everybody puts their own little zhuzh on it, and by the time it gets out, the end user feels all those little touch points. And it's all with the best intention. No one's trying to make a bad product. Each one of the people in your system, in your team, is trying their damnedest to make a great product. But it's very hard to have mind share before the thing exists, right? We all have sort of our own little picture of it, and we're all making the decisions that we think make sense with our part. The EE's doing his part, and the industrial designer's doing her part, and we all are putting our little effort into it, but without that shared vision, it can be hard. So, prototypes to the rescue, I say, and cheap prototypes to the rescue. First thing we think about when we think about prototypes is, what's the point of it? So I'm all for making a lot of prototypes. I like to make them throughout the process. I like to make them as cheaply as possible. We show our clients crazy ugly things that they scratch their heads and then they start using, they're like, oh, I get it, right? I do not care about how beautiful these things are, that you have to take all the ego out of it. But at the same time, I will not just make crap to make crap, right? It has to be thoughtful as to why you're making it. So we think hard, and then we make cheap. There's two major categories of prototype we care about. One is exploratory, and the other one is a validation prototype. They should be pretty self-explanatory from the names, but I will spell them out anyway. When we don't know what we don't know, we explore. We have an audience. We want to know how they solve a problem today. We want to know if we tweaked something in their environment, how they would adapt to it, right? We don't know. We're trying to learn. As opposed to a validation where it's like, we think the antenna will be good enough through this piece of aluminum, but maybe we should build something to test it, right? So validating our theories. Yield design process. We're not going through all of this today. But at a high level, the design process is pretty simple no matter what kind of thing you're developing. You're going to focus a lot on putting together a concept that makes sense, building good theories. You're going to develop it out, you're going to design it, and ultimately you're going to execute on it, right? You're going to get it ready for manufacture, you're going to get it ready for development, for production, etc. So these little squiggly lines I sort of consider stage gates, right? At each point where we're going to move from one phase to the next, I usually like to have a validation prototype. I usually like to have something that checks the box that says, nailed it. At the beginning of each one of these phases, I usually like to have an exploration prototype. There's usually a bunch of questions, a bunch of open items. This is not a rule of thumb, right? I would say you got nine big stages here. You might make 20, 30 prototypes, right? You might, at the beginning, make a ton of exploratory prototypes. And then when you're down in design, you're starting to make a lot of validation prototypes. And then at the end, maybe then you're getting the higher fidelity stuff because you need it for sales activities or for, you know, factory alignment, things like that. So there are still times for fancy prototypes. It's another MVP. How many MVPs do you guys already know? That's acronyms, right? So this is the minimum viable prototype methodology, right? I'm not coining that. I'm not writing a book. It's just what I'm saying. We are always asking ourselves, what's the next cheapest thing I can build to answer my most pressing questions, right? So one that sounds so straightforward, but it really requires two things. One, that you know what your most pressing questions are, and two, that you are willing to spend a little bit of energy thinking about what a good cheap way to solve that problem might be, right? So, you know, we typically, our process is, we'll write all our assumptions, all our big questions out on a board, or put them on sticky notes. I have a little card I'll show you in a minute that sort of facilitates this activity. You know, we sort of slot rank them by how disruptive they're gonna be. So if I found out that I got this assumption wrong, you know, if I'm at the beginning of the project, if I find out halfway through the project that I got this wrong, how bad is that? How much damage is done? Are we talking about a couple days to fix it? Are we talking about the whole business model is flawed? Like how bad is that? And the worse it is, naturally, the higher we rank it and the more we prioritize figuring it out. And then we'll go through and sort of brainstorm what are the 100 ways we could get to that piece of knowledge that we need. So this is specifically not a talk on how to execute prototyping because there's so much good stuff online. I would just be sort of being a Google for you. I will share a couple kind of high level things. So the first thing I said, you know, we got to think about what am I trying to get out of this this test, right? So what kind of type of prototype do I need? Is it about feasibility? Is it sort of a mechanical question? Will this hinge break? Is it too thin? Is that material crappy? Is the ergonomics weird? Is it, you know, a usability thing? Is it understandable? Will the user be able to get it up and run quickly? Or is it the most challenging, the intangibles, right? That X factor. Is it cool? Will people like it? Will they wear it? Will they feel goofy wearing it? Right? All these kind of things that are, ooh, it's a little trickier to get at some of those ones. And we set our goal, whether it's exploratory or validation. And then we look at what kind of fidelity we need. And this is always the hard part, right? Where you always start making it more of a thing than it needs to be. So what's really, how can you talk yourself down in terms of what that fidelity needs to be? So here's a laundry list of things that we use. Paper demos and click through sort of digital demos. I use these mostly in reverse. So I use mostly the paper when I'm demoing, when I'm prototyping digital stuff, and mostly digital when I'm prototyping physical stuff. And that's not just to be like contradictory, but really what I find is when you get outside of the medium that the actual thing you're making is in, it frees you up. You stop getting caught up. You know, when you're making a digital prototype for a piece of software, it starts to become the piece of software. You start to care about the things that aren't important at that point in the process, right? So you're making some sketches on paper and all of a sudden you're free, you don't care, and you're answering big questions. You're putting big ideas in front of users very quickly. And it's sort of the same with the inverse. Puppet and Wizard of Oz is some of my favorite. You can read about those online. That's basically where like a human does the job a computer would do. So you're gonna make this big piece of technology, this big piece of software that's gonna have some great functionality. Well, humans are pretty capable. So you get one of them, you hide them behind the scenes, and you know, if you're testing a conversational voice application, or if you're testing a piece of software, I'll show you an example later where you know you want it to change when somebody does a gesture. Well, that'd be actually pretty hard to prototype that from a technical standpoint. But if I just have somebody watching with a camera that you know we pretend is a motion capture, and oh, he moved his arm left, do the one that goes left, you know. So big fan of that. We keep a lot of craft supplies around, right? It's like, it's going back to grade school. It's so much fun. Like the way in which people can have conversations around an idea when there's props about construction paper, clay, you know, popsicle sticks. It really doesn't matter. Getting physical stuff into the space, people just start to talk with their hands and put stuff in front of each other. Projection's another one I love. So if we're trying to understand the scale of something or how it fits in an environment, might just do a quick digital mock-up and then project it into space. How big will that be across the room from me on that bookshelf, you know? Found hey, if you can beg, borrow, or steal it, if you can rip somebody else's thing apart and put something on top of it, that's always the path, right? And then, you know, all the ones you'd sort of know, 3D printing and laser cutting. There's so many low batch, low cost, sort of manufacturing techniques these days. It's fantastic. There's mail order places. You can have parts back in 2 days. You can have your own great quality 3D printer for a couple grand in your closet. But a lot of that stuff is even too high fidelity for me. A lot of that stuff is like, well, at that point you got to get in CAD. And once you get in CAD, you're going to lose a day. So even that stuff I like to use very sparingly, or keep it really simple. I'm not going to model the whole thing. We're going to do an X and Y axis, and we're going to print those, and now we have a pretty good sense of its shape and scale in the environment. All right, we go on and on with that, but we'll get out of that rabbit hole. So there's a little card that sort of helps with this exercise. If anyone wants this, just email me afterwards. I got a little PDF. But basically the idea is you write your open item. What is it that we're trying? What's my risk? What's my assumption? You write your goal, whether you're just trying to learn or whether you're validating. You write the type, feasibility, usability, intangible. You fill this one out. This is the how much risk do I have right now? How exposed am I? How much damage is this going to cause me? We do 1 through 5. I don't care what you do. ABC, small, medium. Holy crap! Whatever you like. And then we just write as many things as we can think of to try to solve that problem. And we keep sort of pushing ourselves to be like, okay, well that'll take you 3 hours. What could you do in 2? What could you do in 1? What's that cheapest possible thing you could do to test this? And there's a floor to it, right? There's a point where you're like, no one will understand that. I can't, spool some tape around my finger and be like, here, it's our new app. And once we've got one we like, sort of write what the testing plan is. So this is equally important, right? It's one thing to make the thing, it's another thing to know how you're gonna test it, right? Am I gonna get 3 friends and have them over for pizza and make them all touch the thing? How much am I gonna tell them beforehand? What am I gonna tell them afterwards? And then we sort of try to tally up the total investment. What kind of dollars and time am I putting into this thing? And how does that work against this big number? If this is a number 5 holy crap issue, and we're spending 3 days and $400 to figure it out, that's probably not a bad thing, right? It's when this is like and then you've got over here, we're losing 2 weeks of our developer and blowing $1,000 on renting it. That's what you watch out for. So let's look at some pictures because that's more fun. All right.
You call those prototype cards? Sorry.
I don't have a name for them, but if you got one, let me know.
You have to call it something.
Right. Well, it's the minimum viable prototype card system program. I have a book. So I'll share some examples, and then we can chat a little bit if anyone has some questions or thoughts or better ideas. So we're working on a spirometer, a connected spirometer, Bluetooth-enabled spirometer. If you don't know what a spirometer is, it measures lung capacity. Typically used in clinical settings. Very helpful for folks with asthma to track and monitor. It's one of the few things you can actually do to sort of track and monitor asthma progression over time. Childhood asthma is on the rise, so this is a timely device. The idea is not just to connect it because it's fun to put Bluetooth in things, but because we'd actually get a bunch of net benefits out of it. Tracking consistency, education about how to use the product, et cetera, sharing. But really one of the first things we realized is that since this is a kid product and it's not in the clinical environment, it's going to get gross. It's going to get really gross really fast. It needs to be super tough and super cleanable. And the typical way that digital spirometers work is they have a little whirly blade in the middle, a little turbine, goes past an IR laser. It's a lot of little, intricate parts, and it's a perfect place to just build up kid crud. So we did a little research, and we found that there's a way to measure air velocity with a pressure sensor. You have to create a special chamber, blah, blah, blah. So that was so critical to the project's success as to whether we could actually accomplish that and how big the package size would be and what the cost of the components might be. So that was the first thing to do. So here, Adrian just talked for 20 minutes about all we do is build things out of cardboard and pixie sticks. And then the first thing he shows us is our Arduino on a board with a bunch of stuff. But this is, to me, really the point. This is the smallest, cheapest thing we could build at the time. Did we worry about trying to scale to the actual compute we were going to use or the actual wireless protocol? Not so much. What we really cared about is, could we 3D print this sensor and get a decent rate? We didn't bother to tune it. We weren't trying to like build the we were just, this was such a critical validation for us, because if we had to go back, you know, that changed a lot of things. Plus we had to understand packaging size. So ergonomics, when you're talking about, you know, a user base of children, is really critical, right? Little kid hands, they function in different ways than we do. They hold and grip things in special ways. So we had to really get into stuff that we could put in kids' hands very early, and we didn't want to make stuff that was wildly the wrong size or impractical in terms of how the components were actually going to sit in it. So there's a couple. We actually made like 20 of these things. These things, cheap, so now I'm back to cheap, right? We made like 20 of these things. Just gave them a quick coat of paint so they would be really consistent, because we made them out of a ton of stuff and we didn't want that to be distracting. And then the other big sort of point we needed to test about this product was the digital side of it. So it has sort of two components. One is that there's a gamification element for the kids where they sort of get to watch games, blowing out candles, blowing dandelions, playing trumpets, stuff like that. And then there's of course like the reporting and monitoring and tracking side, which is going to be a little bit heavier for the physician and the parent. So we didn't want to spend a ton of time and a lot of money making stuff. So we made simplest, cheapest wireframes we could make to show to the parent. And we stole a GIF of a dandelion being blown off the internet. And we put those two things on two phones. And we went out and we hung out with a bunch of kids. There's a couple whose parents are nice enough to let me share their children with the world. And we went around to their, you know, their houses, got in their environment, sat around with them, let them try all the different blocks, let them try, you know, the different animations, showed the stuff to the parents. And you know, in, I don't know, it probably took us 3 days to hit about 10 homes. We got so much data back, right? We learned so quickly what stuff the parents would do, what the morning routine is look like, where this object's gonna live inside the house, who's gonna be responsible for making the kid do it, are they gonna be bribing them with treats, like is it, you know, a gold star system? We learned kind of what the kids thought, what they responded to, a lot about how they hold things, how they grip things. One of the big takeaways for us was that to use this device properly, you have to have your sort of chest open, your lungs at their full capacity. Kids naturally sitting on things, you know, are kind of get a little crumpled. And so, happy sort of accident, we were looking at the devices that sort of encourage the proper, you know, posture, and this sort of butterfly, whatever, propeller design kind of evolved, where the kids were really liking the pinch grip. You know, they kind of almost do like little mini fists around it. And just by having to be up here, it kind of opens up the chest, right? So great learnings with very minimal investment. A day to carve out a bunch of different shapes, you know, based on an underlay, a day to make some quick wireframes and stick it on a phone, a minute to steal a GIF from Google image search, you know, and we're off. This is a good example of a Wizard of Oz. So we're working on a 4K set-top device that, you know, all the big 4K displays were coming out, and I can't go super into it, but basically a digital experience through a 4K box, much like, you know, your Apple TV or your Fire Stick, any of these sort of things. And so we wanted to do a remote that was very different and sort of really symbolize what was different about this system. And that's a really bad premise, right? Doing something to be different just to be different is a great way to get yourself in a ton of trouble. So picture if you have a Fire Stick or a Fire TV or Apple TV or any one of these devices, Roku, picture your remote. It's a little rectangle like that with the D-pad, little circle and a button. Yeah, they're all the same because it's great. It really works well. It's one of the best, you know, conventions for navigating a, you know, rectangular space. But nonetheless, we had, because I've named all those, there are a lot of products in the market. This was sort of going after a particular subsegment, and it was really important to have something that would be a statement piece, something in your home that would sit somewhere and people would be like, what's that about? And you'd be like, oh, it's the remote. But yet, it couldn't be a statement piece that was a pain in the butt to use. It had to be a statement piece that was awesome to use. So these are some quick wireframes we made. We started thinking about the context of it. And then we just made a ton of different remote shapes. And what we knew was that, based on a lot of the UI work we had done, that we were, TVs are rectangular, big horizontal plane, right? They are in landscape. We were going to be doing a lot of left and right. That was going to be the big gesture that really needed to be accounted for. And so, again, we probably made like 20 of these things, let everyone have at it. What do you think? How do you think you've seen the wireframes? How would you navigate them? What would you build, right? And then what we did is we just set up a little mini living room in our office, and we had people come in and we'd put the thing down on the table in front of them, and we'd have the wireframes up on the TV, and we'd have somebody in the back, with a little Bluetooth keyboard, and we'd say, all right, go ahead and navigate. And you'd watch them sort of, and which, they all took a little learning curve. They were not the D-pad, but we watched the ones that took the least learning curve, right? The ones where people got to the object that they were trying to accomplish the quickest, right? So again, I don't know. I think a couple days for some pretty high fidelity wireframes, and then a day making crazy things in the shop, and we're off to the races. This is a prototype of another level. This is a big grand experiment. So we work with GE's appliance group, and they're very interested in the interactive kitchen and what's coming. And we were gonna help them with this project where it was basically making a giant interactive kitchen island / cooktop that could be a test bed, help them explore a lot of how you can impact eating behavior, how you can try to shift people into healthier eating habits through a more connected experience. So they've had this thing out at shows. It's a very feedback collection tool. It's like the grandest of prototypes. And it's big. It's a big thing. And so none of us had interacted with the 8-foot by 3-foot touchscreen / cooktop in our lives, and so we didn't have a lot of reference for how that would work and how that would feel. So the first thing, the foam core, always the foam core, right? So we basically built one of these things in our office and saw just how giant it was right off the bat. And we learned a bunch of things about how human anatomy and this shape interacted. So it would always have been imagined that you would access this thing from both sides. It'd have a little bar side for hanging out, and it would have an active kitchen side. What you realize very quickly is how short the average human's arm reach is. Not reaching to like straight in and grab something off a shelf, but comfortably reaching to interface. You're not going that far. So you put a foot depth bar on one side, and it really makes the interaction area quite small. It's still iPad size, right? It's still actually a good piece of real estate, but it's not like you chop this thing in half and that's what makes sense. So that was a very quick learning that informed a lot of what else we did. So we made some wireframes, and we sort of devised this rail system where we had sort of the hangout rail that was smaller and would host more of that kind of content. Then we had the more active cooking rail on the other side that could be deeper. And we slowly moved these into high fidelity comps and started building out the software. But we really wanted to interact with the thing, and we had ordered this giant touchscreen from a partner of ours, but this is like a 6-week thing to make. You don't just have 8-foot by 3-foot touchscreens laying around. So they were busy sourcing this big crazy piece of glass from the UK that was so anyway. So we didn't have the time to just wait for that to arrive. So what we could get our hands on was a couple of 22-inch touchscreens from Dell. So we got those and stitched them together. And so we got to sort of play with the UI, get a sense of the flow on that, but then we still weren't understanding the scale, so we got down some 55-inch monitors from our conference rooms and just put them on tables and started using that for scale. So just what's this really quick thing? Just put this thing down, look at it, don't get caught, don't just wait and assume it's going to work out, right? Find that quick, cheap thing you can do. All right, a couple more here. This is kind of a crazy one. We're working with actually some Austin startup guys who are working on a new hand-based gestural input device. And throughout the years, there have been many interesting stabs at this, from the Power Glove on up. A lot of failures, a lot of awkward territory to go into. So again, we started, using wire and tape and just trying to find out what the form factor is. Like, what's the thing you could... Yes, we show these to clients. They put them on, they try them. And instead of having, days of email exchanges arguing back and forth about what thing I project to make sense from my mind, you put it on and go, oh God, that's awful. I could never wear that for more than like a minute, right? Ultimately, we ended up here, which is kind of interesting. These guys had an interesting manufacturing challenge in that we happen to have two hands, and they're not the same, they're mirrored. So This device is basically designed so that you can flip it upside down, the faceplates get reversed, it has the same LED on both sides, and then your fingers are actually dramatically different sizes, it turns out. We thought, oh, all the wires will just be the same. No, then you get these crazy wires. So they just chop the wires to length at the factory, assemble it all up. Pretty small part count. But we only learned that through these experiences, right? We only learned that as we're going to go into CAD, as we're going to go into hardware design, as we're going to be working with the EE, these things will matter because we learn them up front. Simple one, working on a small wearable. Actually, it's a system of wearables. You can wear a bunch. It's kind of for pro athlete level folks. You can wear a bunch at one time. Tracks a ton of stuff. The goal was that you're going to have a bunch of these things. No one's going to want to keep up with 4 or 5 of these things and charge them. It's just a nightmare, right? So hardware is really not what's important about this equation. The data that comes out of it is what's important about the equation. So the business model quickly became these things need to be semi-disposable. They need to last a year, get returned for a discount on some fresh ones, or maybe it'll be a subscription service, or who knows, right? A lot of ways to skin it once you have that realization. So the idea was, can we make it last a year? Can we go low energy Bluetooth? Can we check in only at certain times? Can we build up a bunch of data on the device and then pass that over at certain times? And if we do that, what size battery do we need to last a year? And so that became the defining design criteria. So we took the battery size that we needed and we built a bunch of primitives, right? Just basic geometries. This does not take long in CAD, right? A bunch of geometries, 3D printed them out. Great use of a 3D printer. And then we had like 20 of these things and we taped them to ourselves and we wore them and we tried to run and we said, triangles suck, turns out. Now, if I showed you a rendering of one of the designs for this thing as a triangle, that's the one you would all pick because it looks fantastic, but it sucks, right? So you learn these lessons very quickly. That was the ultimate constraint. That was our first, most highest priority item to check off our list. I got 2 more. This is kind of a funny one. So we were working on this project and we were working with the EE and we were working, one of our designers going back and forth and trying to figure out how to interface this SD card into this thing. And it was just becoming this like chasing of tails thing where it's like no one understood what anyone else was saying about the challenges. So we just printed out the things that we want on the board and we just started moving them around in the space we had to work with. And all of a sudden, communication solved, right? So sometimes prototypes aren't even tools to show outside people, they're to show inside people, right? This is a device that was part of a system for sort of home monitoring, stuff beyond just security, air quality, yada, yada, yada. So you start to put these things in your house, and you probably have a bunch of things in your house already with lights on them. You start to go, what feels good? What feels like creepy and Orwellian? Like what makes me feel like safe? And what is that device trying to tell me that is blinking at me right now? And so really the biggest questions were more about, what kind of presence do you want to have that says, you're safe, everything's good, I'm not creepily monitoring you, I got your back. Also, by the way, this is the status of the house right now all in one glance, right? So that's a challenge of design. It's also a challenge of interface. And projects like this have gotten us into this deal with LEDs. And LEDs are sort of my nemesis in that they are now on everything because they are super good at communicating for almost no money. LEDs are practically free from a hardware standpoint. And with a tricolor LED between different colors and different animations, you can communicate a ton of information. Way cheaper than almost anything else I can think of. But they're really hard to work with. They're really hard to prototype. I am not an electrical engineer. I hate soldering. And so if I want to understand what something's going to feel like, I can do a mock-up, a digital mock-up, in After Effects or something. That's great. I wouldn't take anything away from that. But it's not getting me into the world. It's not getting me on my prototype device. I'm not getting a sense of how it's going to, relate in the context of my actual world. So we work with the EE that we work with a lot to build this product that's basically just a shield for an Arduino that allows you to do hue, saturation, luminosity picking on the fly with knobs, things that designers can understand, and then a bunch of animations. And you can actually hook it up to a computer and do all kinds of fancy animations with it as well. But, and it'll do like 3 LEDs at once. And it just became this amazing tool to really get quick understandings of how things were going to feel and what they were going to mean. And so this isn't an ad for this product, because I don't even know if there's any of them left, but I guess the point in sharing this is that sometimes if you look at your organization, you start to see patterns of prototyping. And there are ways to potentially create tools that then make prototyping even cheaper. So I try to keep an eye out for those things. All right, you know all these points. I've said them, but I'll say them again because it's the wrap-up. Number one, why do we prototype? Why do we do it quickly and cheaply? Because it saves us time. It saves us time in the short term and saves us time in the long run, right? We all want to get to market quicker. It is incredibly competitive right now. Whatever you're working on, so are 3 other people, and they're going to get there before you, right? So we want to reduce risk, right? All too often we just make assumptions. They're such good assumptions. Like it's so easy to be on a team, and 6 people from different disciplines will all make the same assumptions because we have very similar backgrounds, very similar experiences, and it's just so easy to get caught in this. So I question everything throughout the process, right? And the only way to really reduce that risk is to get something in front of either users or investors or whatever it is, whoever this party is that needs to give you validation, or your manufacturing partner overseas, or whatever it is, wherever your risk is to get that stuff out there and get feedback as you go. This is, I think, a point that is maybe less well appreciated, which is creating mind share amongst the team. There's something so special about when a prototype lands on the conference table and everyone from different disciplines starts interacting with it. There is this really cool thing that happens that now we've all had that shared experience. We all know, oh, that is a lot bigger than I thought it was going to be. Whatever that is, we've all had that same very visceral experience. And now as we try to solve it, as we try to design our way out of that problem, we're reacting to the same thing. We're not all reacting to things we've imagined in our heads. It does build momentum too. Things are exciting. Things galvanize the team. People like to see a thing come off of the computer and into the world. And this is true of investors as well. We put very questionable prototypes in front of people with money because everyone reacts when you see something making progress. Everyone reacts when you see how it's evolving and why it's evolving. And ultimately, and of course the best point, is that we make better products when we do this, right? We make experiences that make sense to people. And that's how ultimately we build important brands and loving customers. So that is all I have for you today. I'm happy to answer any questions.
So how long did you spend, or how much money did you spend on that prototype? Like, when did you say this is enough, not to go too much?
Well, there's these little cards. I don't know if when you came in, I don't know if you saw them. There's little cards we use where basically try to come up with this equation. It's not a perfect equation, right? But we try to give ourselves a map to say, okay, how big of an issue is this for us? How much risk are we exposed by? Now, how do we think we can create something that'll answer that question for us? Now, how do we think we can create a cheaper thing, and now a cheaper thing? And eventually we hit a floor where you're not going to get the kind of feedback you want if you go below that floor. Sometimes you push it and you put a thing in front of people and they don't know they can't give you the feedback you want because the fidelity is too bad. So then you crank the fidelity up and you try again, right? But down at that cheap end of the spectrum, everything should be so cheap that you really, even if you miss the mark sometimes, you start over. It's not a big deal. It's not like you put 2 weeks into a prototype to find out it doesn't answer the question you want, right? So I don't know that there's a clear number or clear time.
Just kind of like,
Usually if we're doing something that's just around a quick physical mock-up we want to make, or just a very simple wireframe or click through, anything that's more than a day for me raises a flag. Why? And often there's very good reasons, but that's at least a point where I'm like, I feel like we could do it cheaper.
okay.
Yeah.
Is all your prototyping done on a contractual basis, or do you do some things on speculation?
As in, do our clients pay for all of it?
Well, do you only do things that people ask you to do, or do you come up with your own ideas and then try to sell them to?
Sure, as a company we do both, right? So we're mostly a consultancy. Mostly clients hire us and we help them explore stuff they're working on. But on occasion we do bring our own ideas to market.
Any thoughts around sharing the prototypes with like remote clients or clients who are local?
We will drop things in the mail, like, so most of our clients are actually not based in Austin. I mean, that's just sort of the nature of the size of Austin, unfortunately. We always want more people to be based here. We want more VC money to be flowing into this town. You know, there's a lot of talent, a lot of great ideas here. But yeah, we'll drop things in the mail. We'll jump on a video call and like, look, I'm wearing it. It's weird. Makes me look goofy. So we try to communicate as much as possible. Sometimes if it's something we're gonna 3D print, we'll just 3D print one on their end too. Like, you know, there's a client we have in Chicago, we just send the files and we send them to our 3D printer, we'd send them to a 3D print shop like down the street from them, and then they'd have a courier run it over when it was ready, so.
Engineers have a tendency to never stop, like, wanting to, so the card's a great idea, but how do you create this culture where it's just good enough for a prototype, right? Because an engineer won't want to stop.
Man, it is tough, and designers are the worst too, because we have so much ego in it, right?
Yeah.
If we didn't have ego in it, we wouldn't
Yeah.
drive ourselves crazy and work all night on things. I mean, what we've seen evolve is, you know, culturally, some people just go crazy and put way more than needs to go into a prototype into it, and then sort of see the result, and it's sort of like a self-fulfilling learning cycle. I don't know, it's like, I'll be like, well, couldn't we just tape this to that thing and do this? And they're like, well, I guess, fine. You know, and once you just sort of like keep telling people that they're not gonna be judged for how much it looks like a Band-Aid nightmare, and if you bring it to me and I get learning from it, then you made an excellent prototype. So I think it's just about like encouraging that message over and over again, and almost making it, instead of the shift being competing to make the best thing, trying to shift it to who can make the fastest thing that we learn the most from, right?
What tools?
Cool.
Oh, I'm sorry.
You guys are all set.
Yeah, you go next. What tools do you need in your toolbox to, I mean, 3D printer, Band-Aids,
A lot of Band-Aids, a lot of duct tape.
ceramic rings, what do you gotta have to?
Yeah, I guess it depends what kind of stuff you're working on. If you're working on wearables, for instance, you're gonna want textiles, you're gonna want tape, soft materials, you know, really good hard dense foams that you can chop stuff out of quickly, that are durable, that you can ruggedly test. If you're making like stuff that's more like smart home, for instance, you know, where the scale starts to get up, the finishes start to get a bit nicer, you know, where your end product's probably gonna be in plastics or something, right? You might want more foam core stuff you can kind of box bigger structures out of quickly. So I think it's kind of just understanding the scale and the likely materials of the end product, and then trying to see what the cheap, quick things to play with that relate to that are.
What tools do you use for like click-through demonstrations?
We were using Envision a bunch, and then we got into Flinto recently, which is for Sketch, which is really cool because Sketch has such a great workflow already, and then Flinto will push stuff out to apps, or you can do stuff in a browser as well. So that's been our kind of go-to recently.
Kind of specialized tools that are good for that.
Yeah.
What tools along the same thread do you recommend for your clients, like Balsamic or something super simple? What,
From the digital side?
or from the click-through?
Yeah. Well, pretty much everything we create gets shared with them in sort of a consumable fashion, so they can really experience it as users. I've seen clients prototype in PowerPoint, right? So I think it's whatever tool's not gonna slow them down. Like I've received PowerPoints that have click-throughs in them, where like you put it in presentation mode, and they've made it like navigate through to the different screens, right? So.
PDF for that matter.
Yeah, exactly. Interactive PDFs are great. I think it's like whatever isn't gonna be a big time suck in trying to learn it, right? Because it's a communication tool. You're not making the software. You're not making the app. You're making a way to tell other people about the app you want to make, right?
Can you loosely describe the process by which you draw a contract with a customer? What are your parameters? What are your rules of engagement? Have you actually ever no bid an RFP, and why?
Yeah, so how do we sort of structure engagements? when we like to work so iteratively is how I sort of
Yeah.
take that to mean. The SOW process is always painful because there are always stakeholders that are outside of, you know, probably the person representing the vendor, the partner, and the person on the other end who's really trying to get our services, right? There's always procurement departments, that sort of thing. So, you know, we understand that, right? I think all the time we're operating in the development of products, we're operating in a world of business, right? There's always gonna be these constraints on it, and just like we have to work through that with getting a prototype to move through an organization to champion an idea, we gotta work through it in the SOW process too. So I think it's about trying to put the right words in there where they're protected, right? They have a clear enough set of deliverables that they know at the end of it, they're gonna get the result they want. But that the process in which we get there retains enough ambiguity that we can play as we go, right? The other thing, and this is, I don't think something that scales to everybody, but because we're not a huge firm, you know, and I've come from a big firm background, one of the things that's so sweet about being more of a boutique firm is we don't have a ton of layers of structure ruling, you know, the SOW. So it's like, if we realize halfway through the project that we've got to pivot because you're going the wrong way, then we just have a frank conversation with the client and say, look, this is not the right way to spend your money. Let's do something else. And we have no bid. I think we no bid where we realize that there's not support for the project. If the program isn't properly supported internally, and there's always gonna be, you know, folks that have varying levels of enthusiasm for it. But if it's genuinely not supported, that's a really hard environment to work within because you can't show crappy cardboard stuff because it's just a way for people to naysay, right? So equally as important is it for us to be open to using cheap things and get our ego out of it, you know, our clients have to be open to seeing really weird, cruddy stuff too, that ultimately is saving them a ton of money and a ton of time, because we're not churning up beautiful prototypes, getting models made by professional model shops every time we're looking at something. Certainly there's a time and a place for that. So I think it's just about being really open to how messy the process is gonna be and make sure that everyone can handle it, which of course they will say yes to and then say no to later. That's the nature of the beast, right? Anything else?
Along that same vein, is it hard setting the expectations with your customers that you're gonna get a lot of prototypes and like, you know, we're gonna need quick response and quick feedback on these to be able to make the kind of progress that you want to?
I mean, a lot of them don't necessarily require client participation.
Okay.
So
It might be within your own control.
right, they're interested in the findings, they're interested in progress, they want to get the best possible product to market that has the most differentiators and the best cost structures and all that stuff. So we may do like 3-4 prototypes before a deliverable that we don't need to like gussy up and give it away for them to
Gotcha.
interpret.
Okay.
Hey, up to which extent do you use data to measure where you are and gather new insights, right? Like if you have these long-standing customers, you might know trends and figure it out these are new businesses, right?
Yeah. So how do we use data? So I think we're still evolving as an agency into becoming a more data-driven organization. I think that historically designers are very scared of data, or not scared, they just don't see the value in it. It seems so abstracted from the very intuitive nature of watching a person use something and be frustrated by it. But in any time we take something into the field, we both do, very simple like think out loud exercises where we're like, I'm sitting on the floor with those kids using the spirometer, just watching their hands, listening to their words, and then one of my colleagues is actually taking really thorough notes. And we may have a set of questions we want to ask every one of them, but I may kind of bounce around to get to all of them, but they'll make sure all that data gets captured. So we can actually come back and do at least some basic statistical analysis on the data, not just sort of what our gut reaction was to the data. So, but it's evolving, but it's an interesting field for sure.
For our IoT project, in 3 months, I've embraced 4 different microcontrollers, and these system on a chip or computer on modules really have picked up pace in the past half year, where there's a new one every month that has a price or size or feature or power advantage And it's now got me scared on which one to pick. They're all gonna be running Linux, so should
Yeah.
I just embrace the latest one and go with it and know that the underlying microcontroller might change down the road?
I guess the question is like, how cost sensitive is your end product, and how, like, all right, so the next one comes out right now. You're gonna get an email when you leave. And there's gonna be a better one. It's gonna be maybe $1 cheaper. It's gonna maybe be a little bit faster, and maybe its overall package size is a little bit tiny. Does that change your product? Is that meaningful in a significant way? Because time is also the enemy, right? The longer we get stuck on one of these questions, on one of these challenges, we're not getting to that next level of learning or production, right? So the more iteratively we think about it, the more about, well, this is what we have in this moment. We'll produce against this spec, and that thing will have its lifetime, and at some point we may start our next rev and it may overtake it, and that's sort of the nature of it, right?
Well, ours is an industrial product, so it's less price sensitive.
Right. Well, and what it probably is very like uptime sensitive, right? And like you probably have a lot of, sort of harsh environment stuff or security issues, or you have a lot of other things that you have to be accounting for, right?
Yes, it's targeted towards the smart grid in the energy space, so it's mission critical.
Right. So what you probably care about is not what's the newest, but what's the most stable, what's the most robust in the category, right? So it seems like you may have a little bit of that luxury, right, of course you always want the best thing, the best, newest, hottest thing, right? But it seems like in your environment, locking in on one, and so all of your testing and iteration is about really building a bulletproof system rather than sort of chasing that next best opportunity. Seems like it aligns to the space that you're operating in. But I just met you, so I don't want to tell you you're busy.
My rub would be that device you just described has to have 2 computers in it for 2 different radios and a controller and brains and some kind of interface. So I've got 5 devices in one thing where I'd like to have one piece of silicon. So.
Yeah. I wish I could make the hardware world better.
Yeah.
No, it's a great question. I mean, because we experience how a improvement in sourceable, cost-effective technology can rapidly change the design experience. So, if we're trying to engineer that wearable and we have these insane power usage constraints, and then somebody comes out with a really cool off-the-shelf antenna that cuts 20% use off of our Bluetooth antenna while increasing the range, well, that changes what we're possible to do with form factor and all. But at some point, you got to go, right? So we typically try to work with kind of our best, what's the best right now, and then we usually put a little bit of a little. We're gonna make it a little bit smaller, a little bit tighter. We're gonna get a little more battery, and assume by the time we get all the way through the design process, and we're integrating with our factory, and we're getting into manufacturing, that we're gonna find a couple optimizations. So I guess we're glass half full.
Do you primarily use contract resources or more direct hire?
For
Just what you do?
all of it.
Yeah.
We're primarily a design and strategy shop, so most of our full-time employees come from those backgrounds. In the world of developing IoT devices, there's so many unique skill sets you'll need, and they change from project to project. So, we've spent the past 5 years building a pretty good network, mostly locally, but nationally and overseas as well, of EEs and material experts and you name it. It's going to come up at some point. Antenna designers.
How many direct hires?
We're 10. We're 10 folks. Yep.
And where are you physically located, Pushstar?
We're in the Miller area, the redeveloped airport area, just east I-35 north of the airport. Yeah, so it's fun. We just watch a construction site all day. It's funny. It's like we've made a lot of products in the time they haven't even made a road across. I don't want to judge, but I feel they're just moving the dirt back and forth. It's a good thing this is being live streamed. I'm sure there'll be like a cabal on me. Okay. Anything else before we wrap up?
Do you ever get involved either in a direct way or on a consultative basis with getting your prototypes into production?
Yes, we do. So we work
How do
with
you do
a
that?
pretty broad scale of clients, from like the Fortune 50 guys who have their own hardcore engineering and sourcing folks to entrepreneurs, two-person teams who have nothing. We have a bunch of factories that we have worked with and have built some trust with. We're not a sourcing agency. I would never put us in that box. There are people who do that professionally, who do supply chain validation and, work on your, delivery systems and, do your warehousing and all. That's not us. But, we also don't like to work with a young team and leave them high and dry at one of the most critical handoff portions of the project. So we will interface with factories, whether we've found them or they bring them to the table, and go through that whole process, which is super fun. But they like prototypes too. We have found that, working with factories, the earlier you can send them stuff, the rougher stuff, the things like, they have a ton of institutional knowledge, You're working with folks who do nothing but injection molded plastics, or nothing but extruded aluminum, or nothing but, PCB production. Like, they're gonna have knowledge that you just don't have. And so over-engineering it to the point where they can't give you any of their value is not always the best path. So anyway, that's a talk for another. All right, thank you guys so much.
This is so.
It's a mix, focus on what we're good at and that sort of thing.
What do you do right now?
Well, I have a long history in the semiconductor industry. I have a degree, been doing project management almost exclusively. And one of the reasons I'm here is because of IoT. To me, that's where it's all going.
Yeah.
And I just read this. I would like to do project management.
Yeah.
In this space.
Yeah. That's the nice thing about the consultancy side, right? You get dropped.
I'm always open-minded just to be educated.
Learn a bunch
about
about
what's
it.
going on.
I know, and that's,
Today,
I mean, what drives me is
How much?
just the learning.
Like,
Because it's,
do you wanna create like
every
a
day's
matrix
different, every
frame?
customer's different.
And
project's
then we
different.
target our clients and our projects to fit them.
Going to bed too, I haven't done that since I was in college.
Supposed to go, but you don't be
Let's
such a bad
stay in
idea.
touch.
Yeah.
Right.
You know, give the tools, give
Things that are relevant to our
and then
role,
see what they can
Yeah.
make.
project management.
I mean,
technical.
yeah.
Yeah, everything you've talked about.
We need to,
Send me more about it.
I think velocity needs to
After this year, that,
because it's just
Communication.
creativity will
Status
flourish
reporting.
and funding. You need to have parameters because otherwise it's just too much.
Yeah,
And then
it's-
how do we
Team
evaluate
actually could
how well
contribute
yeah,
an
it's
idea,
vastly different.
influence people.
That's where it'd be great
You
to
know,
talk to them.
not directly engineering,
Projects in this vein,
but
like what we need to
asking
provide.
questions,
Yeah.
testing assumptions.
That's what my head
Because
is.
you're so right about
yeah, and then,
assumptions. You know, a lot of times, like not being part of the team, gives you that
where we
distinct
created
advantage.
something in the app.
Yeah, you gotta drink the Kool-Aid, yeah.
And you have like the makeup thing, you're actually gonna be speaking.
Yeah. That doesn't resonate.
And stuff like that and do something.
But I don't think we should be able to pick
Well,
all
you know,
those
trouble.
things.
I never did it.
And to get a client, you need to go with WPM, of course it's gonna be something.
So,
If you go with somebody like Intel or IBM.
call you.
Yeah, shoot me an email sometime.
Shoot you an email.
Catch up.
And you have to actually
More about
go
the
and
space.
speak
Send
with
you
clients.
LinkedIn info.
Yeah, sure.
You know,
And in the past, a lot of the clients have been.
Good to meet you. All right.
Hi, how are you?
Good.
We are a non-profit here.
Uh-huh.
And we work with high school students, having them do computing work for weeks. And we really like your focus because you have
But because it goes into conduit
how
box,
to do prototyping. One of the requirements of the 4-week program that we have
behind the
to
meter,
do
being
prototype.
go.
And that's been also a big problem because they either do arts and crafts or they do something really cool. So we wanted to
And what
probably
we bring to the
have
table
a follow-up
is
discussion with
Sure.
you to
Yeah,
maybe
yeah.
see
expertise in mixed
how you go
signal
about it.
design.
Maybe you can help us put a little bit of a boundary on how they do prototyping because they have such a short amount of time,
Yeah.
only 4 weeks.
That's
We don't
part
want-
of our problem, is it's just such a spectrum
Targeted
and
specifically
outcome.
at
How old are the
High school students,
Okay.
16, 17.
So, in the past, we've had like different projects with like partners that we found on the internet,
Yeah.
but they're so different, the outline is so different. So like, we go to evaluate our program success, we're like, well, you made a robot that cleans sewers, and you have a little park thing.
Yeah, glued,
You know, it's glued together, so
Yeah.
it's just, it's sort of working, but not, and
Yeah.
we'd love to talk, if you pick your brain, maybe if
So-
you're willing, about like how to establish boundaries, and then find out what do we need to provide within those groups,
Yeah.
and find so that every group can be successful.
Yeah. Okay, yeah, sure. I'll give you a card.
Yeah, this is great.
Well, I've been in the
It's
electricity
really helpful.
for the solar business.
Yeah, and
And
I
I
just
don't
saw
have a card,
that
like, I
make
just started
time
last week.
clock there. That's an actual thing?
What's that? Oh, that's actually, one of the
Somebody?
gentlemen who was up here sitting here, that's his project. He just successful Kickstarter for that thing. It's like a time tracking
And
device.
do you have events like this at your space where?
We don't typically host at our space, but
Okay.
we go like, we like to do stuff at the hardware meetup, and there's a new IoT meetup actually that could be really interesting.
Oh.
I haven't been, but I heard good things.
Proprietary.
IoT focused.
Do you use a lot of maker spaces like tech shops, or do you have stuff?
We have
on
most of the
site?
stuff in our
You have most
studio,
on site?
but we do sometimes use like the tech shop up north if we need
Yeah.
more space
He's
and more
into
tools than we have.
separating
Okay,
the
but you have
water
like a basic, like.
Yeah.
3D printer.
Yeah, exactly.
Okay.
Basic table.
That would probably be a good
saws,
thing to
drills.
also ask you, like Google SketchUp.
Yeah.
Well, how do you prototype? Like, what is the best way to create
Yeah,
Yeah.
prototypes?
yeah, yeah. I
Without
mean,
using a lot of hot glue and,
So I'm
Felt.
and fake glass. Thank you
Good to
very
meet you
much.
guys.
Yeah, nice to meet
Touch
you.
you.
totally reliable.
How's it going?
This was very nice.
Okay.
I really like your car.
Uh-huh.
I used to know a lot of companies, and then you just don't know how long you're going to be spinning on the wheels. I mean, just like a general idea. So that was very interesting. And I was going to tell you
Numbers
about
far
the data
exceed our
with
human
IoT,
population.
when you just give the product to the customer.
Hopefully all the pieces will come together.
Selling
And
that.
I had
They
already
never
had
all the data.
I think
Never
it's a
check, right?
blueprint.
Yeah,
I'm
Yep,
thinking, right?
yep.
Some
Okay,
vision.
okay,
yeah.
so that's,
I mean, that's actually, I think we're probably about to have a big second wave of like, I mean, the big categories like
Yeah.
smart home, automotive, wearables. Wearables, I think, is starting that second wave where like we have enough data back now
Yeah.
that it's time to make that actionable.
Yeah.
It's time to get smarter.
Yeah.
It's not just about cool factor now, it's like,
Yeah, because one of the things that we did is what I was semiconductor
Mm-hmm.
in a company, and sometimes for another point, there was something that I need that was never even, I was not finding the trends.
That's my card.
I was like, oh, did you know that?
Yeah.
Anyway, so that's why I was asking.
yeah.
This is me.
Yeah, been 13.
Thank you, that's pretty much.
I think I
Yeah,
said
thanks for
we
coming.
had a
Hey, Adrian. Great times.
Hey.
luncheon.
Great times.
Thanks.
3 years ago,
It needs to
Mike
be
Howard invited me to, and it was the, I think it was in German.
Sounds super familiar.
Yeah, it's a
Is that here in
NASDAQ,
town?
no, it's an electronics, it's a EAC company.
Okay.
It's a- They have a basic group.
Okay, cool.
Engineers.
You were at our lunch.
Yeah, definitely.
You guys are, they have mechanical engineers and industrial PCB designers, and then they made all the factory PCBs.
Right, right.
They-
Yeah,
they-
more turnkey kind of deal.
Yeah, they did have a design group, sounds like very similar to what you're doing. But that was back in the 90s.
So you're now a council
I've had it for about 15 years.
Cool.
Sometimes people, we're all electrical engineers in my firm, so sometimes, it's just intriguing me, and I'd like to get to know you guys a little bit.
Yeah,
Because,
definitely.
we have people with great ideas and great IP, but they need somebody to.
Yeah,
put it together.
yeah, and vice versa. We run into a lot of folks who are looking for good
So
package.
you're on retainer.
So I'm good.
Good.
I'll